Okay, so today we're diving into a mission that's really going to reshape how we see our planet.
Literally.
Yeah, literally.
Yeah.
Imagine a satellite that can detect the ground shifting just millimeters.
Millimeters.
Yeah, millimeters track a forest growing leaf by leaf and even provide crucial data for predicting tsunamis.
That's NISAR.
That's NISAR. So
NISAR.
NISAR is it's the first ever dual frequency radar imaging satellite,
Really?
meaning it uses both L-band and S-band radar.
Wow.
Think of it like having two sets of eyes, each capable of seeing through different layers of the Earth.
Cool.
It's a joint effort between NASA and the Indian Space Research Organization,
ISRO.
ISAR,
Okay.
set to launch in early 2024.
This is big. This is a massive collaboration.
Yeah,
And it feels like the whole world is watching.
it does.
I was reading an article that's called NISAR, a perfect blend of two cultures and a creation by two sets of craftsmen,
Oh, wow.
which I thought beautifully captured the spirit of this partnership. It really does. This kind of international collaboration is crucial for tackling global challenges. And what better challenge to address than understanding our own planet?
Absolutely. So let's break down who's bringing what to the table. I understand NASA is providing the L-band SAR,
You got it.
which I guess is like one of those super-powered eyes we were talking about.
Yeah, one of the sets of eyes.
Mm.
NASA is also providing some of the engineering payloads, so the brains behind the operation, if you will.
Uh-huh.
ISAR, on the other hand, is contributing the S-band SAR,
Okay.
the launch vehicle, a GSLV rocket, and will be leading mission operations once NISAR is up and running.
Wow. So it's a true partnership, each side bringing their expertise to the table.
Absolutely.
But let's get to the heart of it. What makes NISAR so unique? The articles keep mentioning this sweep SAR thing. What exactly is that?
Sweep SAR, that's the secret sauce. It's a radar technique that allows NISAR to collect an immense amount of high-resolution data very quickly. It's like taking a panoramic photo, but with radar allowing NISAR to cover a vast area with incredible detail.
Okay, so I'm picturing like a super detailed Google Earth constantly updating.
Yes.
But what does that mean in terms of what we can actually see?
Right.
What kind of detail are we talking about here?
We're talking about being able to distinguish individual trees in a forest, measure the subtle rise and fall of the ground due to volcanic activity,
Wow.
or even track the movement of glaciers with millimeter precision.
Really?
It's a level of detail we've never had before.
Okay, that's impressive.
Yeah,
And it's doing all this while constantly orbiting the Earth.
constantly.
How often are we getting these updates?
NISAR will map the entire globe every 12 days, this high repeat cycle, combined with the high resolution and the larger swath.
Okay.
The area covered in a single pass means we're getting a continuous, incredibly detailed picture of our planet's surface.
So it's not just about seeing more, it's about seeing it more frequently, right?
Right.
Almost like watching a time lapse of the Earth changing.
Exactly, and it's not just about pretty pictures. NISAR is tackling three major areas of study: ecosystems, deformation, and the cryosphere.
Let's start with ecosystems. What kind of impact can NISAR have in that realm?
Well, think about the Amazon rainforest. We know it plays a critical role in regulating the Earth's climate, but it's under constant threat from deforestation.
Uh-huh.
NISAR can help us track these changes with incredible precision, providing data that can inform conservation efforts and policy decisions.
So we're not just passively observing, we're actively using this information to protect these vital ecosystems.
Precisely. And then there's deformation.
Okay.
This is where things get really interesting.
Uh-huh.
NISAR can measure tiny movements in the Earth's surface, giving us a better understanding of earthquake and volcanic activity.
Okay.
Imagine being able to predict volcanic eruptions with more accuracy or identify areas at risk of landslides. The implications for disaster preparedness are huge.
That's a game changer, especially for regions prone to natural disasters. It's almost like having an early warning system for the planet.
That's a great way to put it. And finally, we have the cryosphere. NISAR will be keeping a close eye on our ice sheets and glaciers, tracking their changes to better understand how melting ice is impacting sea level rise. This is crucial information for coastal communities around the world, allowing them to adapt and plan for the future.
So we're talking about a single mission that can potentially impact every corner of the globe,
Yeah.
from protecting rainforests to understanding earthquakes and preparing for rising sea levels. This feels monumental.
It is monumental, and to really grasp the scope of NISAR, I think we need to dive into some specific examples from the source material.
Okay.
These will really bring the mission to life. Are you ready for that?
Absolutely. Let's get into the nitty-gritty details.
So one of the reports highlighted NISAR's potential for monitoring bathymetry changes along the Indian coasts.
Bathymetry changes.
Yeah, so we're talking about incredibly precise measurements of the underwater landscape.
Okay, so it's not just what's happening on land, but also beneath the surface of the ocean.
Right.
What's the significance of that?
Well, think about coastal erosion. Rising sea levels and changing wave patterns are constantly reshaping coastlines around the world.
Right.
NISAR's data can help us understand these processes with unprecedented detail, allowing us to create early warning systems for coastal erosion, potentially saving lives and property.
So we could actually pinpoint areas that are most vulnerable to erosion and take proactive steps to protect them.
Exactly. And it's not just about protecting coastlines. Understanding bathymetry changes can also help us optimize shipping routes, identify potential hazards for underwater infrastructure, and even discover new marine resources.
It's incredible how one set of data can have so many applications across different fields.
It speaks to the interconnectedness of our planet, right?
Yeah.
And that brings us to another fascinating example. NISAR will be observing sea ice characteristics around India's Antarctic stations.
Antarctic sea ice. Now, that's something I don't think about every day.
Right.
Why is that important?
Antarctic sea ice plays a critical role in regulating global climate and ocean currents. By monitoring its thickness extent and movement, NISAR can provide crucial data for climate modeling and help us better understand the complex interplay between the polar regions and the rest of the planet.
So it's like adding another piece to the puzzle, helping us see the bigger picture of how climate change is impacting our world.
Precisely. And let's not forget about the practical applications closer to home. Remember those oil spills we talked about earlier?
Yeah.
NISAR will be able to pinpoint their location, allowing for faster and more effective cleanup efforts.
Okay, so it's not just about science and research. It's about real-world solutions to pressing problems.
Absolutely.
Oh.
And then there's the whole area of understanding vegetation changes.
Yeah.
NISAR's data will be vital for global carbon stock estimations, which are essential for tracking our progress in mitigating climate change.
So we're talking about monitoring forests, tracking deforestation, and even estimating how much carbon is stored in different ecosystems. It's like having a global inventory of one of the most important elements in the fight against climate change.
You got it. And this brings us to the 3 mission phases of NISAR:
Okay,
launch, commissioning, and science operations.
let's break those down. We know the launch is targeted for January 2024 from the Satish Dhawan Space Center in India aboard a GSLV rocket.
Yep.
But what exactly happens during the commissioning phase?
The commissioning phase is like the first 90 days of school for NISAR. It's all about making sure everything is working properly. They'll be deploying the boom and that massive 12-meter radar antenna,
Wow.
testing all the engineering systems and calibrating the instruments to ensure accurate data collection.
So it's a critical period of testing and fine-tuning before the real work begins.
Exactly. And once everything gets a passing grade, we move into the science operations phase, where NISAR will spend the next 3 years diligently collecting data mapping the entire globe every 12 days.
It's amazing to think about the sheer volume of data this mission will generate. Did the reports mention how they plan to handle all that information?
They did. NISAR is expected to generate over 85 terabytes of data per year.
Per year.
Per year. To put that in perspective, that's roughly equivalent to 20 million songs or 100,000 movies.
Wow, that's a lot of data.
So yeah, it's a lot of data.
I can't even imagine trying to organize my personal photo collection on that scale, so how do they plan to make sense of it all?
Well, they're investing heavily in developing advanced data processing algorithms and cloud-based platforms specifically designed to handle this data deluge. They're also committed to open data sharing, making the information accessible to researchers worldwide, which will foster collaboration and accelerate scientific discovery.
It's great to hear they're making the data accessible to everyone. It's like throwing open the doors to a massive library of knowledge about our planet.
It is.
But with all this focus on data and technology, I'm curious about the human side of this story. Were there any personal stories from the scientists and engineers that stood out to you?
There were one article I read highlighted the story of a young engineer who played a crucial role in designing a key component of the radar system. She spent months tackling complex challenges, drawing inspiration from her childhood fascination with space exploration. It's a reminder that even the most groundbreaking scientific endeavors are fueled by human passion and perseverance.
I love that it's so easy to get caught up in the technical details and forget that there are real people with their own stories and aspirations driving these incredible missions. Did they mention any other stories that resonated with you?
There was another story about a veteran scientist who had worked on several Earth-observing missions. He was initially skeptical about the feasibility of NISAR, given its ambitious goals and technical complexity.
Really a skeptic, what changed his mind? Was it some groundbreaking technology or a sudden epiphany?
It was something far more human. He was deeply impressed by the collaborative spirit of the project, the dedication and expertise of both the NASA and ISAR teams. He witnessed firsthand the power of international collaboration and the shared passion for advancing scientific understanding.
It sounds like it wasn't just about the science, but about the people, the shared dream of pushing the boundaries of what's possible.
Exactly. It's a testament to what we can achieve when we work together toward a common goal, and NISAR is a shining example of that. But beyond the human stories, I think we need to delve into the nuts and bolts of this satellite. What are the technical marvels that make this mission possible?
Okay, let's get technical. What are we dealing with here?
Well, NISAR's radar system is mounted on a structure called the Integrated Radar Instrument Structure, or IRIS for short.
Iris, got it. What is it attached to?
It's attached to a spacecraft bus, which houses all the essential systems you'd expect: power, attitude control, thermal management, communication.
So it's like a mini spacecraft dedicated to keeping those radar eyes working.
Exactly.
What about that massive 12-meter antenna we keep talking about?
Yeah, that's where things get really impressive.
Yeah.
Both the L-band and S-band radars share that single massive reflector antenna. It's a marvel of engineering designed to unfold in space like a giant origami structure.
I can only imagine the precision involved in designing something that has to unfold flawlessly in the harsh environment of space. It makes you appreciate the ingenuity of the teams behind this.
It does. And speaking of ingenuity, how do we get all that data back to Earth?
Yeah, 85 terabytes a year can't exactly be beamed down through your average Wi-Fi connection.
Not quite. NISAR has a high-rate science downlink system that transmits data to ground stations strategically located around the world. It's a constant stream of information feeding our understanding of the planet.
It's like a digital heartbeat, constantly monitoring the Earth's vital signs.
I like that.
But this brings up another question. We've talked a lot about the technical aspects of NISAR, but what about the data itself? What kind of insights and discoveries are we hoping to unlock?
That's the most exciting part.
Yeah.
This data will revolutionize our understanding of Earth's systems.
Okay.
For example, in the realm of ecosystems, we'll be able to track subtle changes in forest health, monitor the effects of drought and climate change on vegetation, and even assess the impact of human activities on biodiversity.
So it's not just about collecting data, but about understanding the intricate web of life on Earth and how it's all connected.
Exactly. And when it comes to deformation, NISAR's data will help us map fault lines with unprecedented accuracy, monitor volcanic activity for early warning signs of eruptions, and even study the slow, subtle movements of tectonic plates that shape our continents.
It's like having X-ray vision for the Earth, revealing the hidden forces that drive geological change.
And let's not forget about the cryosphere. NISAR will give us a front-row seat to the drama unfolding in the polar regions.
Oh, yeah.
We'll be able to track the movement of glaciers, measure ice sheet thickness with incredible precision, and gain a deeper understanding of how these changes are impacting global sea levels.
It feels like we're on the verge of a new era of Earth observation, where we can see our planet breathing, changing, and responding to the forces that shape it.
It's an exciting time to be alive, wouldn't you say? And NISAR is leading the charge. It's more than just a satellite. It's a symbol of human ingenuity, international collaboration, and our collective quest to understand our place in the universe.
It's a reminder that even in a world facing complex challenges, we're still capable of achieving incredible things when we work together. And I, for one, am incredibly excited to see the discoveries that emerge from this mission.
As are we. NISAR is poised to unlock a treasure trove of knowledge about our planet. Who knows what mysteries it might unveil, what secrets of our world are waiting to be discovered.
Well, on that note of wonder and anticipation, I think we'll wrap up our deep dive into NISAR. It's been a journey through cutting-edge technology, groundbreaking science, and the inspiring stories of the people behind it all.
We hope this deep dive has sparked your curiosity and given you a glimpse into the future of Earth observation.
And as always, we leave you with this thought. What changes on our planet are you most curious about? What discoveries do you think NISAR might make that could benefit humanity?
Until next time, keep exploring, keep learning, and keep looking up at the stars.